This is a real data center from Binghamton University in New York that is part of a government and industry-funded research consortium called ES2. Future Facilities belongs to this consortium and has access to this data center to perform studies. It has a modern design with containment and monitoring and cooling system automation that was designed to maintain availability and efficient use of capacity resources at the same time. In this example, a business unit wants to install a pod. The capacity requirements of this pod are within the data center's capacity ratings. On this basis, it was predicted that the pod could be installed without a problem, and the request was approved. After installation, 2 IT units in the adjacent aisle lost cooling capacity and set off their alarms. This behavioral change was overlooked by the prediction. The methods used to predict performance missed this behavioral change, which led to an unexpected performance problem. The risk of a temperature-related failure increased even though the supply of cooling and airflow matched the demand from the IT equipment. The inability to predict data center behavior not only caused this problem, it also greatly limited the visibility of options to solve it. There was only one option the data center management team was certain would fix the problem, and this was to cool the whole room down until the alarm stopped. So this approach eliminated the potential outage, but at the expense of capacity utilization. This configuration was using 91% of the available cooling to support an IT load that was only 45% of the available power. And this highlights the problem. Current tools and techniques lack the capabilities needed to account for data center behavior and performance. Let's go back to the beginning and plan this change with a digital twin. First, let's return the cooling system to its original settings. This overheats the servers again. From this point, let's use Digital Twin to design a solution for this request. Digital Twin simulates the physical behavior that drives data center performance after the IT pod has been added. The simulation process returns a result in a few hours. Here, we see that the Digital Twin simulation has identified the overheating servers. Without simulation, the only option for meeting the capacity needs of the servers was to provision more cooling capacity from the room. But with Digital Twin, the root cause is clear. This is a local airflow problem, not a room-level cooling problem. This problem can be solved without having to provision more cooling capacity. This can be seen more clearly by isolating the cabinets that are interacting with each other. From here, Digital Twin simulation capability was used to design a solution. Any fix that can be imagined can be simulated. With the airflow problem in mind, we will swap the location of the 10 kilowatt racks and run the simulation again. This solution looks promising. It solved the local availability problem and saved capacity for use in the future. And this can be seen clearly by comparing before and after. This configuration meets availability and decreases capacity resource utilization by 16%. And it also reduces chilled water system energy consumption by 5%.